Okay, so welcome everyone. Let's discuss the first two problems of today's bi-weekly contest. So the first problem is find indices of stable mountains. This was a pretty easy, or you can say the language of the question was a bit trickier, I guess. I don't know. Let's see. So there are n mountains in a row, and each mountain has a height. Okay, so how you are given the height? You are given it by an integer array where the ith index denotes the height of the ith mountain. So the interesting thing here is a mountain is called stable if the mountain just before it has a height strictly greater than the threshold, and it has been explicitly said that zeroth index mountain is not stable. So you have to return an array consisting of indices of all the stable mountains in any order. It's fine. So what it is trying to say is you have certain mountains, and for that to find the to define a stable mountain, you have been given a threshold. Let just this be the threshold. So what it is trying to say is this mountain will be stable because here this mountain has a height that strictly surpasses the threshold. Even for this mountain, this is also a stable mountain. Why? Because the previous one has a height that is strictly greater than the threshold. Similar case with this mountain. So basically what it is trying to tell you that look for any mountain at any index I, for I has to be strictly greater than 0. So what it is trying to say is look back, that is look at I minus 1th index. If you find the size, the height more specifically of the mountain to be strictly greater than the threshold, you are safe. Push back into the array and just return it. So the same thing I have done here. So I have taken the height, and I have taken the okay. So I have taken the height. I have taken the answer error that I'll be returning. So what I am doing is for every I minus 1th, for every ith index, I am just checking if the back one has a height strictly greater than the threshold. If yes, it is my answer. Otherwise, no. Okay. So let's move on to the second question. So this was a pretty much tricky question for me. I mean, yes, I observed an interesting thing that I thought I could share. So what it is trying to say is you have to find a safe walk through a grid. So you are given an m cross n binary index. M here denotes the number of rows, and n here denotes the number of columns. For me, m cross n is bit out of the ordinary, so I would use here n cross m. It sounds much familiar. So you can start on the index of the so you start on the upper left corner on the 0,0th index. Okay, and you have to get to the lower right index. That is the if this is the grid, you have to start from here. You have to go here by any path. You can travel left, right, up, down in all the four paths. And for any cell I comma j, if there is a 1 present, then it is considered unsafe and it will reduce your health by 1. Okay, great. Return true if you can reach the final cell, that is this cell, with a health value of 1 or just greater than 1. So let's try to understand it with an example over here. So, okay. So if you see here, if I have a 1, 0, 0 and 0, 1, 1 and 1, 0, 0, and if I have a health of, let's say 2, so I will be standing over here. So for standing over here, it is a 1. Please do not misunderstand it as any other digit. It is a 1. So for standing at the very first index, your health will be going to be decreased by 1. So now you will be traveling ahead with the health of 1. So you can go over here, you can go like this. So if you go here, this is the 0th, this is a safe cell. Let me just change color. This is a safe cell. So you can go here, your health remains 1. If you come at this cell or at this cell, your health will again decrease by 1. So here it will be 0, it will be 0. So your goal of reaching the bottom right cell with a health value of 1 or greater than 1, greater than equal to 1, has been explicitly destroyed. So what we can do is we can do the all-time favorite DFS, BFS, anything. The interesting thing that I found here is, okay, so because we are given, we can travel in any direction, in all the 4 directions. So in all the 4 directions, if we go right, up, down, left, so we always have to, consider the cell which we have visited before this, right? We have to keep track of it as we do in DFS or in BFS. We have a visited array, and what we do in that visited array, we mark 0 if it is unvisited, the cell is not visited till yet, and if it has been visited, it becomes 1. So the same thing I was trying to do over here is, let me just show you. So this is the safe thing, because every new cell has to be checked whether it is safe or not safe. So I had a vector of vector visited where n cross n, and then I had a queue with tuple, because I had to keep in mind the new column, the new row, the new row, the new column, and the health that I come with. That is the health that I'm bringing with me. So I have to keep track of that too. Okay. So the interesting thing starts over here is, I just find that if my starting index is having a length, having the index value to be 1 or it is to be 0. If it is 1, let's decrease our health value with 1. And if unfortunately we get here at the starting point itself, we get 0, then our dreams are shattered and we return a false. Otherwise, we push it in a queue and visit it. So here the most important thing, that most important, what I would say, the notice point of this whole video is this line. Because if you take here 1 instead of health, if you take here 1 and anywhere, wherever you visit and you take the same thing, so your code will fail. Why? Let's deal with an example of this. I should have written somewhere. So if you would consider this example. Okay, so if we are, let's say we will be starting with n is equals to 6, right? So if we are starting here, the first time our health will decrease, it will be 5, and we will put 0 comma 0 comma 5 into a queue, right? And from 0 comma 0 comma 5, we can go over here. We can go over here. Let's say we define what our directions are going to be. Is it doesn't matter what you define your directions to go. So first of all, I'll be incrementing y, then I'll be incrementing x, and the same way decrementing will work. So if I'm incrementing y, I'll be going here. So this point 0 comma 1 comma, and the health will be 4, and from here I'll also be going down. So it will be 1 comma 0 comma 4. Now it has been popped out. So the most important thing here is, because I have gone here, now a queue has a FIFO nature, first in LIFO, last in first out, no, first in first out, yeah. So the first one that has gotten will be getting out. So because of this, you'll be visiting this cell. Because of this, You'll be visiting this cell with a health value of what? 4, right? Fine, 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 fine. We are doing fine. Okay. And because of why I am incrementing this, first y will be incremented. So because of this cell, you'll be visiting here also with a health of 3. And because of 3, you'll be visiting this cell with a health of 3, right? You can see the difference. If you come via this line, you'll be visiting with a health of 3. And if you come via this line, you'll be visiting a health of 4. You see, just keeping a track of whether this cell has been visited or whether this cell has not been visited, it caused me blunders, because for me, if I'm traveling from this cell to this cell, if I'm traveling from this cell to this cell, this cell has been traveled by me, so I cannot go again here. I know it is looking a bit messy over here, but you're getting what I'm trying to convey to you, that if I have 1 1 1 and if I have 1 0 and 0, so why we are traveling by this line, we'll be reaching with the health of 3, and with this line we'll be reaching with the health of 4. So my initial approach to just store the value of health. So you might also say that let's instead of first incrementing x, let's first increment y. That is a sane solution. So let's see what will happen if I do here 0 and then 1 and then 0, right? And to do this has been 1, and instead of this, let's control x and control this, and if I submit it, let's see what will happen. So the initial running has been passed. Let's go. Oh shit, is it the same example? So my output is false here, and they are expected true. So if I take this, control shift C, no, control C, and if I just draw it out here, 1 0 1 1 and 0 0 0 1 and 1 0 1 1 and 1 0 0 1. So where it is actually failing, you can see, and you have an health value of health is equals to 4. So what right now it is happening, we have a straight line. If we go from here to here, we can reach, but because we are trying to we'll first increment x, so this line will be incremented first. You're getting first this cell, then its parents, then again the first one will be the x, incremented x, and then you will reach this cell over here with a health value of 1, where you could have reached this cell with a value of 3. You have now reached this cell with a value of 1. So for every cell that you are traversing, you have to keep in mind the health value that you will be reaching at that cell with. So you have to keep in mind that. So if I just write here h health, and over here, if I can just do this and then control Z. Okay, sorry. New HEA is greater than this, and this will be NHEA. So if I just pass it on for initial test, okay, this has passed. Final test. Oh, it got accepted. So this was pretty interesting thing. Like, you have to keep track of the help that you come along with. So yes. So thank you for being here. Let's see you in next video.